All right. Let's look at 6 and 7 from the review. Give the order and classify. So the order is the number of rows by the number of columns. And then classify, it can be square, a row. If it's one row, then it's a row matrix, sorry. I'll just leave that in. If it's one column, it's a column matrix. You'll see these in as answer choices. I don't think it's going to give you a row column, a row matrix or a column matrix. But you will see a square matrix or it's none. So, again, if there's exactly one row, you had a matrix like this, that was just like numbers, that would be a row matrix. If it was just one column filled in, that would be a column matrix. So let's look at number 6. We consider the rows by columns. So the rows go horizontal, and of course the columns go up and down. So the number of rows, we have 4 of them. 1, 2, 3, 4 rows. And then we have 4 columns as well. So this is a 4 by 4. That would be the order. And 4 by 4, the numbers match. It makes a square matrix. So it's just counting the number of rows by the number of columns. If they match, it's a square matrix. The elements of the matrix don't matter. It doesn't matter that one of these is pi, one of these is a fraction. They're positive, they're negative. We have a 0. The only thing that matters is the number of rows by the number of columns. So 1, 2, 3, 4 rows by 1, 2, 3 columns, a 4 by 3. If you ever need to do, make your own matrix in the calculator, it asks you, what is the order? You tell it how big to make the matrix. So this is a 4 by 3, rows by columns. And that is not a square matrix, so this is classified as none. Some of these are going to go real quick, and hopefully are very easy for you. I know you could probably do like number 8 in your head, but show work in case you make a mistake. So find 2a and simplify. Simplify in this case is just, talking about the fraction. So 2a, capital A, is our matrix. And we're just multiplying by 2. That's all we need to do here. So 2 times negative 3 is negative 6. 2 times positive 3 is positive 6. 2 times this 3 is positive 6. 2 times 5 is 10. 2 times 8 is 16. And of course, take any of these off to the side if you want. 2 times 1/2, the 2's cancel, and it becomes 1. Or 2 halves make a whole, however you think about it. So number 8 is a pretty easy one. You're just multiplying the elements by the given multiplier. Number 9, determine if the points, and then you're given 3 points here, 0, 2, 4, -2, 9, 1. Determine if these points are solutions to the system, and then we have 2 equations here. X minus 3y equals 5, and 2x minus 9y equals 4. And so you just need to do this 3 times. You're just going to test the point for the equations. It would need to make both equations true. So let's take the top equation. Again, that's our x, that's our y. So x becomes 0. Then we have minus 3. Y becomes 2. And we set it equal to 5. The 0 in front does nothing, but -3 times 2 is -6. -6 equals 5. This is not true. And it has to make both equations true. So if it makes one equation not true, then we can automatically throw it out. Say hi to Mango, everyone. Are you leaving? And then you can just keep doing this. Plug in these points for the x and the y. This is all worked out on the review key, but I guess we could keep doing some of these. I'll just do 9, 1. None of these end up working. But let's look at 9, 1. X becomes 9 minus 3 times 1 equals 5. And so we get 9, and then -3 times 1, because we do our PEMDAS, we multiply. That's -3. 9 minus 3 is 6. 6 does not equal 5. I don't even need to bother plugging this into the bottom equation because it does not work. And so it just asks you if each of these points is a solution. The other way you could solve this is to, as we'll be doing shortly, you could use the addition method and just find out what the solution is, and then you'll easily be able to say whether the points are a solution or not. Let's talk about number 10. You're probably wondering about number 10. I looked in ALEKS and saw, well, this probably just was so weird that I looked in ALEKS to see what the other, I can click on the problem and hit try another, and I click on the explanation, and I see that I did this like for 10 times in a row, and every time it gave you a pretty normal set of equations that would graph easily. It asks you to use the graphing method to solve number 10, which in this case, I'll just let you see, I worked it out. This is the top equation in green. I'm trying to get it in y equals mx plus b form, because it tells us to solve using the graphing method. And it just seemed like such a weird problem to use the graphing method on. And in fact, I could see that Professor Molina used the elimination method on the page below this, because he probably also thought it was such a weird one to solve by the graphing method. This does graph, though. If you get them in y equals form, I'll show you on the calculator. Zoom in. So here's both equations, and we can hit, we can look at the graph by hitting the graph. So the lines do intersect, and to talk about that a bit, you'll see the answer option, the system has exactly one solution. Exactly one solution means it's intersecting at a point. And there is a thing you can do in the calculator to find the intersection point. You can hit second trace, which brings up the calc screen. So I want to calculate the intersection. So I hit 5, and then you just hit enter 3 times. First curve, if you get to higher level math courses, it's like, is it to the left of the point we're considering? We hit enter for yes. Second curve, is it to the right of the point we're considering? And we hit enter. And then guess, we hit enter again. And then you can see, hopefully, that it tells us that the intersection is at -1 and 4. So, yeah, a weird problem. Every time I looked at try another, it was a problem more like number 11, which works very well as far as graphing. So we'll look at number 11. But you could use the elimination method to find x and y. You can get these in y equals mx plus b form and graph them. It is going to ask you to graph them. So get it in y equals mx plus b form, and then you're going to have to use that little, what is it? It's like in a box with a little asterisk or something. Use that plot a point feature if you get something weird like 7/3 or 22/5 as your y-intercepts, like we did on number 10. So number 11 is already in is already in y equals mx plus b form. It's in function notation there, but it's y equals mx plus b form. And so we can just graph these easily. Because number 11 also asks to be graphed using, or solved using the graphing method. So let's do 4x minus 5. That's our first row. So we start at the y-intercept, -5. And then, so that's our b. And we have a slope of 4, which is the same as 4/1. So from this red dot at -5, I'm going to go up 4 and over 1. And I'll do that a couple of times. And we can connect that line with some sort of straight edge, which I can't really find. Let's hope we make a good enough line. Oh God. And now, let's graph row 2 in green. -5x plus 4. So plus 4, that's our y-intercept. That's the b, the y-intercept. And then the slope is -5. So we will go down 5 and over 1. So down 1, 2, 3, 4, 5, and over 1. And there it is. I can do that again, but 1, 2, 3, 4, 5, 1. And then this is a steeper line. So again, number 10, I don't know why it populated such crazy numbers for something that's meant to be graphed and meant to be easier than problem number 11. But your 10 and 11 should, work out like this. It's in y, get it in y equals mx plus b form if it's not already, and then graph them. And the point of intersection, that's our one solution. The exactly one solution, and where is that point? So this is at 1, -1. I guess I'll stop there for this one.